differentiation, they learn calculus. But you ask what is integral calculus, they might not know. So today we are going to understand what is integral calculus from the basic, and I will be giving some very basic examples, and then follow by why do we need integral calculus. Of course, we need it because we want to apply it, okay, in different fields, especially engineering. A lot of application involving integral calculus and differential calculus also, of course. So some simple applications will be shown, and then finally we will see how to perform some basic integration, right? So that you can see that sometimes you really need to learn the techniques in order to apply it in a real life scenario. Okay, so these are the topics covered in this presentation. All right, so to start with, students, look at the face of these two persons. All right, of course, I actually get this from the internet. Who do you think is the first one who developed calculus? Based on what you see on the screen, if you look at their face, Newton, I think everybody understands this and know Newton very well. All right, at least here the name are very familiar. Another person is Leibniz. Okay, so who do you think? Just make a wild guess. If you look at their face, who developed or who invented calculus first? What do you think? You can make a simple guess. Maybe you can type in your chat box. Okay, a little bit of response. Who do you think invent calculus first? Is it Newton? Is it Leibniz? Oh, second one. Okay, I know because the name also so difficult to type, right? All right, the pronunciation also very difficult. Okay, Leibniz is German, I think. All right, Leibniz. All right, the second one. Oh, Gottfried. Okay, Ken. Wilhelm. Oh, how do you know? All right, second one. Everybody agree is the second one. Okay. Okay, so if you Google, students, if you Google or you ask ChatGPT, they won't give you a single answer. No? All right. Thanks for your response anyway. All right. Actually, there was a debate, argument as to who invented calculus first. So based on the history that I read, I also verified with internet. Okay. I also asked ChatGPT, So actually, Newton is said to have shared his work earlier than Leibniz. Okay, something like 20 years earlier, no? Okay, as compared to Leibniz. But then why people say that? Maybe you Google Leibniz name will come out and saying that Leibniz is a person who invented calculus, because Leibniz officially published in a journal earlier than Newton. A few years earlier only. Newton published it officially a few years later than Leibniz. But there was evidence that Newton has shared his work with his colleagues and also friends. There were evidence. All right. So at the end, there was controversies. All right. And then today, most people will say that both of them has developed or invented calculus independently, because it's hard to know exactly who come out with the idea and develop it first. So you see, even history sometimes cannot be sure. All right, so just to let you know. So today, if you Google or you look at the Google, you will see that they will put both of them develop calculus independently. All right, accepted as such. All right. Okay, so calculus deal with two branches. Differential calculus is focused on finding the rate at which quantity change. You always do differentiation. Actually, you find the rate of change or the slope. Okay. Today, what we are going to do is integral calculus. This branch is about accumulating small quantities to find the total. So it's accumulation of small parts, infinitely many small parts. Its accumulation is called integral calculus. Okay. In Chinese, there is a word called 微积分. Actually, is the calculus. All right. So what is integral calculus? Okay, let's see. Let us start with some very simple example. Look at this one without using calculus, students. This is just some common sense. Can you make a guess what is the answer? Okay, a car is traveling at a constant velocity of 20 meter per second. That means 1 second can travel 20 meter. Travel for a duration of 10 seconds. Find the distance traveled by the car during this time. So, can you make a guess? No need any calculation, just use your mental calculation. Look at these slides. What do you think are the total distance travel? Travel for 10 seconds, and the speed, so-called the speed in the same positive direction, we call velocity here. Velocity is 20 meter per second. Every second, travel 20 meter. So 10 seconds, what do you think is the distance traveled by the car? I got some answer. Let me wait for a few more answer. Oh, very good. I got answer already. Okay. How about the rest? Do you agree it's 200 or can it be 20? Yeah, I'm looking at my handphone because actually I couldn't see your replies. That's why I also joined using handphone so I can see. So I got 20, got 200. All right. So looks like you also realize your own mistake. Actually, you know how to calculate this, just maybe typing too fast. All right, I can see. All right, so thank you. Okay, very good. So the response from you is correct. 1 second you travel 20 meter and constant speed, constant speed. So 10 seconds, 200. So no problem. So this one, no calculus, no need calculus. All right. But once you want to use calculus, students, you will get the same answer. Later we will do. Okay, that is where I want to bring up your understanding. All right. You may have gone into doing all the difficult integration directly, then you forget about the basic. So the purpose is to expose you to a little bit of what is integral calculus. All right. So got it? Without calculus, everyone will know the answer. All right. So students, you see, if you draw 20 is a straight line, horizontal line here, you see on the screen for 10 seconds. So velocity on the y-axis, time on the x-axis. Area under the curve is 20 times 10 because it's a rectangle. So you can start seeing why we need to find area under the curve. This is one only. I still give other applications. Actually, there are many applications actually is finding area under the curve. You may not know, but you continue, you start doing it already. All right, so this is an example, okay? So if you want to find the distance travel for this case of velocity against the time, you find area under the curve. Because the speed is constant, no problem, no need calculus. All right, so come, let us look at the second one. All right. What is integral calculus? Let us look at a few examples. Same example, I just changed the velocity only, students. All right. Again, no need to use calculus. Let's see. A car starts from rest and its velocity increases over time. Start from rest, stagnant, and then the velocity increases over the time. And the function is velocity is 2t. T is the time. Velocity in meter per second. Find the distance traveled by the car over a period of 10 seconds. Still the same thing like just now, 10 seconds, students. Okay. But now it's you see, now if I ask you to use mental calculation, I know that in a way, a little bit hard to imagine in a few seconds. All right. But if I draw it on a graph, let's say I already prepared last turn so that everybody can see. You see the velocity 2t is a straight line with the slope 2. So one way for you to look at it is when time is 10, velocity is 20 now. You see I draw here already. Okay. So it starts from rest. When time is 0, velocity 2 times 0 is 0. So this is a straight line. To find the area under the curve, again, we don't need integral calculus because this is a triangle. Triangle. All right. So the distance under the curve will give you distance by the car. All right. So based on this, again, no need calculus. Okay, we'll use calculus later when we find that we cannot have a shape that allow us to directly know the area under the curve. Okay, so for this question, what do you think is the distance traveled by the car? The distance traveled by the car is the area under the curve, velocity. The curve is velocity. What do you think? So if you are able to look at it and give the answer, maybe I wait for you to type in your chat box. Area under the curve is a shaded area. What do you think? I got the first answer. Okay. I wait for a few more. Because sometimes the first person give already, the other people, if wrong, somebody will follow. No, I have this experience. Sometimes if the right one, many people will follow the right one also. So I want to see a few. Huh? All right. 100. How about others? Okay. I have 4% already, 100 meter. Okay. Okay, that means your answer is correct. Of course, your answer is correct. All right. So students, yes, because the triangle, to find the area and the curve, you times 10 times 20, and then you divide by 2 because triangle. All right. So you see, students, you try to imagine, just now if I didn't show you the graph, I directly ask you, maybe you won't be able to directly give me an answer, but once your graph is shown, you are finding area under the curve. All right. So come, let us go again. The next one, we increase a bit the difficulty. Increase a bit. Okay, so it's 100. You are right. Yes. Bingo. Stop a bit. Actually, I try to advance my slide. Okay, can maybe my internet here not very strong. Okay, so students, a car starts from rest. Same as example 2. Velocity now is another function. Increases over time according to this function. Quadratic function, example. Okay, just now we have constant, example. One second one we say is a straight line. Okay, and the third one is a quadratic curve. It can be any curve actually. All right, depending on whether the car travel at a different speed at different time. So this one says that the car travel according to this function 1 over 5 t squared. Find the distance traveled by the car over a period of till 10 seconds. So students, this one, if you are saying that you can use mental calculation, then your mind should be something very special. We are not using integral calculus. All right. I don't deny that there are people who are able to do that. But these are very, very special people. All right. So for us, most of us will not know. Oh, sorry, I cannot answer. Because the velocity curve is 1 over 5 t squared. Okay. So let me represent it, the graph. This is the graph. Okay. So the velocity here, 1 over 5 t squared is a quadratic curve. The area under the curve represents the distance traveled by the car. So if you don't use calculus, what should we do? I think for those who have learned calculus, you may have learned before. You use trapezoidal rule, you use Simpson's rule, etc. Of course, if quadratic curve, you use Simpson's rule, you get exactly the answer. No? All right. If you have not used calculus, so for this one, okay, let's see. The distance is hard to know directly if you don't use calculus. But initially, when this is developed, actually the concept behind calculus, just now you know this Newton and Leibniz, who come up with this idea first, actually hard to say already until today. So that's why they say both of them also. Right. So, okay, so students, the same curve I reproduce here, the same curve. I want to find area under the curve. All right. Assuming that I don't know such things called trapezoidal rule, Simpson, I don't know. No, I use a very traditional one. I use rectangle. Use 5 rectangular strips to approximate the area under the curve. Lebih kurang lah. This is to find lebih kurang area loss di bawah graph. All right. So you actually everyone know that if I use a rectangle, try to find the area under the curve, sure there are some error because this part is not covered area under the curve. This one extra exceeded the curve. All right. So when I use rectangle, in a way also it can be like, okay lah, this area, okay, example, okay. Wait. Let me draw a bit. Okay. So this area is not under the curve, extra one. Okay, but never mind, this one, this extra one counted in by this rectangle, maybe you can put here. Example, just example lah. So overall, still not too bad. This part extra one can put here. So based on rectangle, you can see that, just an example, when the time interval, okay, let me move this away for a bit. Okay. So you can see that from 6 to 8, this interval of time is 2 seconds. 2 seconds. Okay. So the speed is about 10 meter per second. Okay, here. But actually, when it is 6 seconds, the speed is not 10, it's about how many? 7 point something. Here you can see 7 point something. All right. Okay. So because we just want to do an approximation, so we find the area of the rectangle. Example, this rectangle, the area is 2 seconds times the speed is 9.8 meter per second. 9.8. So that's why I write here. Okay, the fourth rectangle, the velocity is 9.8. How do I get 9.8? The midpoint is 7. So 7 put inside here. 7 put inside here. So 7 square, 49 over 5. I get 9.8. This is how I get the height. All right. So 9.8 times 2, I get 19.6. So I get 19.6. So the area of this rectangle, 9.8 times 2, 19.6. This rectangle, I do the same thing. I find the height. The height is 16.2. How do I get it? 9 here. Put inside here. 81 over 5, 16.2. The interval is still 2 seconds. So total, when I add up this, all the rectangle represent area under the curve. Is not perfect because there are some space here, not filled, some space extra. So I get 66. I add up this. Okay, it is the velocity times the time interval. So the total area of the rectangle approximate the area under the curve, 66 meter. Distance travel about 66 meter. It's not accurate, this one. Okay. Let us go to the next one. Remember just now we said integral calculus is the accumulation of many small parts. This one is, the part is a bit big. Rectangle is very big. We want to use a smaller rectangle. So from 5, okay, is a big rectangle. So now if we use 10, what will happen? If we use 10, so if I use 10 rectangular strips, you can see that the error in a way minimized already. All right. So I split it into 10 rectangle. So for example, there are 10. This rectangle that I in red, midpoint is 7.5. So 7.5 square over 5. I know the height is 11.25. This is how I calculate the 11.25. The height of the bar here. Times the time interval is 1 second. So the distance traveled in this 1 second is 11.25. Okay, so you can see. So same thing. For this 1 second distance travel, how much? Then the second last rectangle, 14.45 velocity for 1 second. So 14.45. So I will add all the rectangle, all the 10 rectangle here, the area, which approximate the area under the curve is 66.5. All right. So this is how, if you say the old-fashioned way, before calculus. Remember last time we don't have computer, many years ago. Okay, or you have computer, but a computer to do some computation take very long time. Now maybe you will say that if I don't know integral calculus, I also can use computer to split this into 100 rectangles. Then it will be very accurate already. And you are right if you think that way. You're right if you think that way. So this one 66.5. All right. Again, not very accurate. Again, not very accurate because here not covered by this rectangle. This one extra. So you can see that. So there are still some inaccuracy there. All right. Next, students, let's see. If I further make the rectangle smaller and smaller, I use 15 of them. The area under the curve I get is 66.59. Same question, students, same questions. If I use 20 strips, that means 20 rectangles just now. If I make it 20 strips, of course the rectangle become very thin now. All right, which is exactly what we want to bring up the concept of calculus. Then the total area I get is 66.63. All right, so I go back a bit, students. You see, this is 10 rectangle. No, if I make it become 20, that means I have more rectangle. Then the time interval become very small. Calculus actually your speed become constant. Then I tell you that the time interval that I count here is 0.1 seconds. Then the speed will be constant already. That is the whole basic of concept of integral calculus. Accumulation of small parts is an integral calculus. For any time interval, if your time interval is from 7 seconds to 8 seconds, you see, actually the speed is not constant. No, just I use rectangle, assuming it's a constant. But if I tell you that exactly from 7.49 to 7.51, what is the speed? Almost fixed here. It is here. And then your rectangle will be a very thin rectangle. Then it become more accurate. Okay, so this is the concept of integral calculus. All right. So come, let's see. Okay, a little bit of notation. When you add a number of rectangles, you use many rectangles, your time interval become almost zero. Just now time interval 1 second, 2 seconds. This now time interval 0. So the total distance is actually velocity times the interval of time. This is accumulation of small quantity, which is integral calculus. All right. So in calculus, I think you have gone through this notation before. We say we integrate from time 0 to 10 seconds this velocity function. The velocity here is 1 over 5 t squared dt. Okay. So students, actually I want to ask you, if I ask you not to use integral, I'm sure some of you maybe know how to do this integration. Not to use integral calculus, no need to do calculation yet. If I use more and more strips, that means very tiny, thin rectangle, what will the area be? What do you think? No need to do any calculation yet. What do you think is the area B? All right. You see, when I use the 5, it's 66. Use 10 strips, 66.5. 15, 66.59. 20, 66. Increase a bit, right? Increase a bit. All right. So if you make a guess, actually it's not easy to guess, I know. All right. If I use 25, maybe 66.6 something. I didn't calculate, I also don't know. Maybe still got increased a bit from what I see here. All right. So that is why no point making guess. If you have a computer, you don't want to use integral calculus, you put number of strips is 25, what happened? 30, 35, until it become this number doesn't change anymore. That is the final correct answer. All right. We call it numerical methods because it's basically add up the numbers. That's why we call it numerical methods. All right. Okay, so students, how to do this kind of integration? I think maybe some of you know, or if you have done your revision all right. Let me move to the next slide. Okay, hold on. Okay, Kennedy. All right. I find that I still got stuck a bit, maybe due to the bandwidth. So integral calculus is like this. To find area under the curve. Again, students, why want to find area under the curve? There are many applications actually you are finding area under the curve. All right. So this one is a very general one. When you learn calculus, you say find area under the curve from A to B. And if your function is fx and fx dx, yes, as simple as this, because there are many applications. So we actually kind of covering what is integral calculus now, just now. Okay, so let's see. Let me advance my slide. I know that it doesn't move yet. Oh. Hold on. Just hold on for a while. I try to escape also cannot. No mind. I let me stop sharing and share back a bit to see how whether it's okay or not. Okay, sometimes has to be like that lah. So never mind. All right, you can see my small slide there lah. Okay, everyone. Never mind. I make it big back again. See whether got problem. I think usually no problem lah. All right. Okay, so advance the slide. Everyone can see the slides. Okay. Basic rules of integration. Can you see my slides now? Because just now I know that it's stuck a bit. Okay, no. Okay. Let me share. Let me share. Share again. Have to reshare again. Share again. Thanks for letting me know. Okay. Okay, share again. I found that there's no problem when I'm not in presentation mode. Looks like there's still some limitation. Maybe it's the internet bandwidth, not a problem. Okay, so area under the curve. Okay, if your x is from A to B, you integrate from A to B. And then your function is fx, and you put it there. All right. I think now you can see my slides already, the big slides of basic rules of integration. Am I right? You can see that, huh? Can I have your response, students? Can you see my slides, basic rules of integration? Yes. Okay, thanks for the response. Very fast. All right. So I'm sure maybe you have some exposure, students. The basic one actually is the most important one. If you know the basic already, then we discuss about more difficult one, then you can see the flow. Otherwise, you don't know why the more difficult one you want to do in a certain way. If you integrate a constant, A is a constant, then ax plus c. So I quickly go through just a fast way. Okay, it looks like it's still stuck. So, okay. Give me a few more minutes. It's still, I try to advance my slide. It is stuck. That is the thing that we have to deal with online sometimes. It just come out after I press 10 times first. So very sorry for this kind of scenario. So when you integrate 5, you get 5x. Many of you still remember that integration is the reverse of differentiation. You can see the right hand side. If you differentiate 5x, you get 5. Differentiate number, you get 0. That's the reason why we integrate a number, you get number times x plus c. All right. Okay, the next one. When you integrate x power n, you increase the power by 1 and then divided by the power. So x power 3, increase the power by 1, x power 4, divided by the power 4. So I suppose maybe most of you know, no problem. Now, okay, now smooth already. When I click one time, it advances the slide. So rule number 3, if you have a number times a function fx, example 4 times x, you can take out 4. What it means? Integrate only those functions involving x. So that's why 4 you just maintain. Integrate x power of 1 become x power of 2 over 2. Rule number 2. And then simplify, you get 2x squared plus c. So this is just a recap only. I think most of you have learned this, if I'm not wrong now. This is in basic calculus 1. So if you have addition or subtraction of functions, what you say here is you can split them. You can do it part by part. So if, for example, half x squared plus x power negative 2, you can actually do this part. First, half maintain x squared, you get x power 3 over 3. Plus is still plus. X power negative 2, integrate become x power negative 1 over negative 1 plus c. Right? This one, most people can use their common sense and do. Plus is still plus, minus is still minus, can split. Right? Some of you may wonder why they really need to mention in this rule. integration, okay, plus and minus can split. There are some function or some operation in mathematics, doesn't mean that if plus minus, you can split them. Integration can. That's why I need to make it a rule and then tell people that plus or minus, you can split them. Do part by part, no problem. Just do according to using part by part. Okay, and finally, the last one, number 5 and number 2, there are some similarities. If you have A is a number, B is another number. Ax plus B power n, same thing, increase the power by 1, divide by the power. The only difference is if you got Ax, then you have to divide by A. Okay, so this is a quick example. So 3x plus 2 power of 5, you get 3x plus 2 power of 6 over 6. But don't forget, if this is 3x, you have to divide by 3. So the difference between number 5 and number 2 is a little bit here only. Okay. All right, so this is some basic rules of integration. Most of the students are in calculus 1, the first calculus should have learned, so we don't spend too much time here. All right. And then the definite integral. Just now you integrate from A to B. What it means is if you integrate fx, you get capital F, then just put in B and then later put in A, minus that. All right. So this one also majority have no problem from what I see. If you integrate from 1 to 2, this function, so 3x squared, integrate, you get 3x cubed over 3. 3x cubed over 3, so become x cubed plus. Integrate 2, 2x. Put 2 inside here, you get 2 power 3 plus 2 times 2. So 2 power 3 is 8, 2 times 2 is 4. So you get this, the first one, and then minus, and you put 1 inside, you get the second part here. All right. Again, I still feel that majority has no problem. That's why I quickly do it as a recap. All right. These are called fundamental theorem of calculus. Okay. Never mind if you don't know the name of the theorem. Fundamental, the most fundamental for definite integral. Why we call it definite integral? There is a definite answer come up. There is a definite answer come up. So with these students, let's come back. A car is traveling at a constant velocity of 20 meters per second. Find the distance traveled by the car using integration. So if I ask you, can you use integration? You use integration, what do you get? Okay, let me directly show it. It's not too difficult, students. It's not too difficult. Of course, we don't need to use integration, the integral calculus so-called, because rectangle, everybody know how to find the area of the rectangle. Right? So if you use integration, it's a very short one. A very short one. Okay. Yeah. Just want to mention that this is how we do. Integrate from 0 to 10. And then the function is 20 dt. So just one step, let us show it directly. 20. Okay. Let me write. 20. Integrate a number, then the number t. Okay, remember if dt and then dt, if dx, then it's 20x. So from 10, 0 to 10. Put 10 inside, you get 200. Minus, put 0 inside, you get 0. So 200. So of course, you use integral calculus, sure you get the answer, same as the area of the rectangle. So no problem at all. No problem at all. Let us quickly go through so that you can see actually, students, integral calculus is very useful, especially when the shape is irregular. Okay, so example 2, back to example 2. Velocity is a straight line. Okay, now velocity is a straight line. So to find the area under the curve or to find the distance traveled, we can do integration. So the integration here, many of you already know how to integrate this. 2 is a number maintained. Integrate t, you get t squared over 2. Increase the power by 1, t power of 1, increase the power becomes t power of 2 over 2. Then you cut and cut. And then you put 0 to 10. So 10 squared is 100. 100 minus 0, 100 lah. Finish. So of course, you use integration also very equally fast for this simple kind of questions. Now, okay, come back, students. Okay, I've been talking quite long, students. All right. I would like the students, students, can you try to use calculus now? Because if without calculus, a little bit difficult to guess, right? Let me get back to the earlier a bit. Students, you see, start again. Okay, so students, how to use integral calculus to find the area under the curve? Because this is a quadratic curve. It's not a straight line. It's not constant. So maybe I give you a few minutes, see whether you are able to give me the answer. Students, distance is this one. Integrate from 0 to 10. This is a function of 5 square dt. What do you think? I'll wait for you for a few minutes only. Few minutes. Okay, I let you work out your answer. And then if you are able to get your answer, maybe you type in your chat box. Zero to 10, 1/5 t squared. I got the first answer. Not very sure. Fine. I'm very happy that you already answered the questions. All right. Okay, let me wait a little bit, a few more minutes, see whether others get the same answer or different answer. Okay, I got 3 Muhammad here. Very good, very responsive. All right. I think you must be able to do quite well. All right. I know that it's not too difficult, but the fact that you can see it and do in such a short time and then give a response is actually very good. Very good. Very, very good. Right. So since all 3 persons get the same answer, usually if all 3 persons get the same answer, should be got high chance of being correct. Since high chance of being correct. All right. So let me work it out. Work it out and then you see whether correct. This is for those who have not got it yet. So 1/5. Integrate t square, I got t power 3/3. Multiply, All right. So this is 0 to 10. So okay, let us write nicely. 1/15. T power 3. Actually, we can put like that one. Number can also be taken out, or you want to put inside also no problem. So you get 1000/15. So put 10 inside. So 1/15. This number is 1000 minus 0. So 1000. 66.67 meter. Okay. Bingo, very good. Okay. That is, you already know what to do. All right. So you can see integral calculus. So this Leibniz and Newton has developed calculus so many years ago. All right. And then this rule come out so that we can get the area under the curve so fast. All right. It can be any curve. Of course, there are some functions are very difficult to integrate one, which you learn how to integrate more difficult functions. All right. The next one, students. The work done by a force. Okay, I understand that some of you are in engineering, civil engineering, chemical engineering. So we talk about the work done by a force directed along the x-axis from x0 to A to B. You can see here. The work done is you integrate from A to B the force and then the x. Okay. If the force is constant, we know the force time distance finish. Force time distance. All right. But if the force is a variable, force keep changing one, the force is not constant. Then you need to use integral calculation to find the work done. So again, first, you are finding area under the curve or not? When you want to find the work done, area under the curve. Right? So example, I have an example. I might wait for a while. Start again. I press a few times. I suspect is my internet bandwidth here got a little bit of problem today. Just now I tried to test, it's not consistent. So no choice. I tried to test a few locations. Okay, I try again. So bear with me for a while. Okay, sometimes stop sharing and then share back. Okay, I have stopped sharing. Then I share back. Wait. Okay. Okay, I start sharing back. And then I do this. Oh, sometimes no choice. So, example, find the work done by a force. Say that we purposely give you a cubic curve. This one quadratic cubic. It can be any other function also. So a force keep changing on the force. Okay. Depending on where is the location along the x-axis from 1 meter to 2 meter. So to find the work done, you integrate to find area under the curve. So the work done is from 1 to 2, and then this one is your force, and then this is your work done. So remember just now we said that if some function here, ax plus b power of some number, you can integrate directly using the rule of integration. You see, if you want to multiply it 3 times and then only integrate, you will get the same answer. But what if this is 13? Then you cannot expand it. Okay, so we do is 2x plus 1 power of 4 over 4. But because the 2x here, you need to, down here is 4 times 2 become 8. Then you put in, then you get your answer. So this is just to demonstrate the applications. Okay, this is the reason why. Remember our title? What is integral calculus? Why you need calculus? Because you want to do different kind of integration to find area under the curve. Right. Let us continue. Okay, another example. All right. Another example of why. Assuming that the carbon-14 in a living human body is 15 nanograms. About that, in the human body, in fact, there are some variation. If for a very big size person, maybe 15.01. Don't know. Small size 14.99. Okay, there are some variation actually. All right. So about 15. So we start at 15. After death, carbon-14 decays at a rate proportional to the amount present, with a half-life of 5730 years. So this one has to be established one. Half-life of carbon-14. Decay means keep reducing one. Carbon-14 keep reducing after a person die. All right. Okay. While alive is 15 nanogram. Okay. Upon death, then it decay, decreasing. So this one has to be established. That's why the rate of change of the amount present, N is the amount present, amount of carbon-14, rate of change is dN over dt. Proportional to the N is the amount present. We put a negative K here because decay. Right? So suppose the amount of carbon-14 in the dead body is measured and found to be 14.5 nanograms determine the time since death. So this is one way that can be used. Okay, how long a person has died can just measure the carbon 14 in the body, right? So of course the basic is here. No? We start from this is called a differential equation. If you have not learned it, you will learn it later on, of course. Okay, so for application lessons, you see, dN dt, the rate of change of amount of carbon 14 is negative something because decay, decreasing, negative Kn. So when we integrate both sides, n we bring to the left hand side, n become 1 over n. Right hand side maintain, dt bring up. So you can see here, when you integrate both sides, later you want to put n on the left hand side and time on the right hand side. In fact, can be also, and left side or right side can be interchanged. For this one, and the left hand side, time on the right hand side. So how to integrate 1 over n, dn? Integrate a constant number, no problem with it. It's just kt, so negative kt here. All right. So due to this one, that's why you also learn all these kind of things. We are not going to go through in detail. So there are many kind of integration you learn in your calculus. Maybe some of you learn a little bit, some of you learn more already. Okay, I was told some will learn a bit, some learn more already. So that's why you need to pay attention and learn all kind of integration. So for our case here, students, you integrate 1 over u is ln u, ln modulus u plus c, for example, in this case. Okay, so the second case, 1 over 2x dx is half, and then 1 over x is ln x plus c. Right? So when you integrate 1 over u, ln u. You integrate exponential function, what to do? Integrate this kind of function, all kind of integration. All right, this is not the main thing we want to discuss today. Is to show you some applications. And just now, what is integral calculus? Okay, so let us proceed. On, start again. Okay, I stop sharing and share back. From what I see, looks like there are some problems. Okay, very sorry for that. I found that when I present at home, today I'm in the college. When I present at home, no problem because my home, actually 300 is more than enough. Okay, 300 meg is more than enough. Right? Maybe at my college one today, the internet got a little bit of problem. Okay, so students, these are some of the integration, and then so come back to here, students. Actually, I'm thinking that if got time, then we go through a bit more detail, but never mind. Now let us quickly go through. So when you integrate 1 over n, you get ln n. N is amount present, which is always positive, so ln modulus of n become ln n still. All right. So from here, integrate negative k, you get negative kt plus c1. Okay, I won't go through the details. I put in based on the block properties, and then I think I don't want to go through too detail already. Then there are some calculation, and you can get this equation out. Actually, you need to know how to do integration, and then from the ln you convert to exponential function. All right, this is in your mathematics. Maybe before you do your calculus. All right, can be learned. Never mind, can be learned. So after you put in the information, you get your n on the left hand side. Okay, your time on the right side. E is a constant called exponential growth function. 2 point something. So for this case, the n is the amount of carbon 14. If for this that body, that person, amount 14.5, you put in n 14.5 and solve for t. Then you find that after you solve for t, you get 280 years, 0.25. This is how we use carbon 14. All right. Sure, in chemistry, you talk a lot about carbon 14, all right? And then in calculus, no, we need to do integration, integral calculus. So the details on, I'm sure you will learn now if you learn a little bit of integration. All right, there are many types of application. So it shows that integration is very useful. If not, it's hard for us to come up with a useful equation. COVID-19 students, exponential growth and decay is an exponential growth. E is involved. Yes, E is involved in the model. But different country come up with a different model, and then people say the China one is the most accurate one, and then US have a different model. Okay, depending on some assumptions made. All right. Okay, so since trigonometry and hyperbolic integrals, why do you need to learn also different kind? Because you need to apply them at different scenario. Okay, so I just show it only, huh? All right. Okay. I just show it. You will learn all this kind of integration. Okay, so let me start again. Stop sharing. Wait. All right. So maybe I go through here lah. Yeah, go through here. The last example so the last example. So for civil engineering, for example, mechanical, one example, one application is when you have fluid and then you have a vertical wall, the liquid force against the vertical wall, there are some formula. Let me see. Oh, I may exit a little bit, so no problem. I may exit a few minutes. All right, I just look at my screen. No problem. Then there are some formula. I go through. W is the width of your wall. If you measure from top to the bottom, okay, your liquid is from A to B. Liquid, for example, water density is 62.5.
Mr. Go, we cannot see your screen.
Okay. Let's see. Wait. Thanks for telling me. Yeah, sometimes you thought it's actually the internet lag a bit, right? Thanks for telling me. Actually, I forgot to share again after I unshared just now stuck. So there are some formula to get the liquid force. We talk about water a lot. So for example, the water density is 62.5 pounds per cubic feet. Okay, I already show you already. So for example, for those who do civil engineering, okay, you have this water pipe lah, and then you have your liquid lah. Then you want to design a cap on one end. How strong you want to design your cap? Then you have some formula. Okay, so unfortunately, I don't think I have time to go through detail. I think that doesn't matter. There are some formula, and then you need to do your integration again to know the force exerted against your cap. Your cap is a vertical here. All right. So from here you can see that integration again. And then the integration here looks like it cannot be done directly using whatever we discussed just now. But you can see that this part 9 minus x squared, if I differentiate, I get 2x, negative 2x, which is some number x here. All right. 2x, here 2x. So dealing with this kind of thing, maybe some of you already see that if you have learned maybe basic over already, you learned a little bit advanced already, then some of you may know that I use integration by substitution, because if I differentiate 9 minus x squared, I can get 2x. Another part. Okay, so with this, let me just show the answer. All right. Actually, I'm thinking of showing you the integration by substitution. If I differentiate 1 plus 4x power of 4, I get 4x power of 3. So I will let u to be the first part. And then when I differentiate u, I get 4x power of 3 dx. And then integration by substitution will follow. Right? So to solve these questions, actually you can see, looks like a little bit of techniques needed. Integration by substitution before you can know the force exerted against the cap. Then how strong should the cap be designed? How tight? All right, it should stick to your one end of your pipe. Things like that. All right. So I know that those students who have done a little bit advanced one, you also learn the integration by parts, because this is integration by substitution, integration by parts, integration by partial fractions, integration by trivial substitution, many of them. All right. So learn your calculus well, so that when you go to other applications in other subjects, then you find that you have already got some basics. You won't struggle so much. All right. So I think that is enough for today, students. We have covered what is integral calculus, which is accumulation of small parts. All right. But accumulation of small parts need to do a quite lengthy calculation. That's why we do integration. Why we need integral calculus? Because a lot of application in engineering, be it with civil engineering, chemical engineering, even more in electrical engineering. In my college, we offer electronic, electrical. We didn't offer this chemical, civil. All right. We also have a lot of this kind of mathematics course before the student take their core subject in civil, electronic, electrical engineering. All right. So we have the what, why, how we have touched a little bit only, because the how is the whole calculus course, calculus 1 or 2 or 3 students. So you will learn all right. So let me stop sharing, and then let me open back my this one. Okay, so students, that is all from me. All right, that is all from me. Anyone have any question? Feel free to ask. I exit a bit. I think so.